Good afternoon, all the students. Just wait for 2 minutes. Our friends may have to go there. Yeah, all the students in the last class already we are discussed. There is a what about our molecularity of a reaction. Okay, now we are going with the what once again that whatever the molecularity of the reactions here. Yeah, listen carefully. What is the molecularity of a reaction? Okay. Yes. Once again, in the last class we are discussing, but not updated. We are not completed. Molecularity of a reaction. So very important. How many molecules are present in our chemical reaction? What is the molecularity? Which one is called a molecule here? You know very well. Combination of atoms or elements is only called what? Molecules. You know very well what is the atomicity. Suppose you have to take a PCl5 somewhat PCl5. What is the atomicity? How many atoms are present inside it? There is a 1 atom phosphorus, chlorine is the 5. Totally how many? 6 atoms are present inside it. Okay, clear or not? Yes, and O3 ozone it is. Okay, na? It is a 3 oxygen atoms are there inside it. Okay, element is a one only, but atom number it is. Like that only in a one reaction, how many reactants are there as a yes? Reactants are there in a chemical reaction. That is only called what? A molecularity. How many molecules are involved in a chemical reactions? That is only called a molecularity. Whatever the products is formed, that is not a matter of for us. But how many reactants are there? How many reactant molecules are there? That is only called what? That is only called what? Molecularity. The number of molecules present in a chemical reaction in the reactant side. Okay, clear or not? The number of molecules present in a chemical substance or number of molecules are contained in a particular chemical reactions. That is only called what? Molecularity. Yeah, once check it. What is the molecularity? Yes, number of reactant of molecule in a any of the chemical reactions is only called what? A single step of a reaction is only called what? Molecularity. Got it or not? Now there is a we taken one equation PCl5 gives rise for us PCl3 and as well as the chlorine. Yeah, what is the molecularity of this particular? What is the molecularity of this particular chemical reaction? Yes, there is only one. Okay, clear or not? How many molecules are there here? Only only one molecule, phosphorus pentachloride. Okay, it is a give the trichloride and as well as the chlorine. In the reactant side, how many molecules are there? Only one molecule is only there. That's why it is a called unimolecularity. Okay, now one it is there, it is a called unimolecularity. Got it or not? And next, after this, we are considered here one more thing here. I am taken two HI, these guys. Okay, now yes, H2 plus I2, hydrogen iodide. How many molecules are there here? Two molecules, but one HI is one of the molecule and it is multiplied by the two. How many molecules it is? Two molecules only there here. Sorry. It is a bimolecular, this is a unimolecular. Suppose you have to take it is a sodium oxide. Sorry, nitrous oxide. It is a combined with the what? Oxygen. How many are here? Then it is a bimolecular or otherwise trimolecular. Okay, now how many molecules are there here? Only two molecules are there. Okay, don't confuse about the number of atoms present in a molecule. Either may it is 6 or may 7, whatever may be it is. Suppose I am right here K2Cr2O7. Number of atoms are present in there is a what totally 11. Okay, but it is not called a different molecule. It is as a single molecule. It is a together, it is a one substance only, one molecule only. Understand all of this? Now that it is become what? NO plus O3. This is a what? A bimolecular only. Got it or not? Yes, NO2 plus O2 is a formed here. Yes, clear or not all this? Bimolecular. Next to come to here, the carbon monoxide. The carbon monoxide as oxygen. How much particles are there inside it? 2CO. It will be gives plus CO2. 2CO2. It is a form. Now tell me how many molecules are there? Yeah, how many molecules are there? There is a two molecule. There is a one molecule. Two carbon monoxides. One oxygen. Got it or not? There is a 2 plus 1. How many? 3. Trimolecular. Got it or not? I hope you got it here now. Whatever number of molecules are there, okay, now that will be not okay, now yes, called as atomicity. Atomicity is not considered here. The number of molecules are present in the chemical reactions in the reactant side. Not think about the our whatever product side it is there. Don't concentrate on the product side now. Whatever the things are there in a product side, but the reactant side, how many molecules are there? That is only called as molecularity. Understood all of you? That is a called what? Molecularity. Yes, I hope you got it. Yes, this is the called molecularity. Yeah, this molecularity has also contained some properties. What is the properties are there for a molecularity? Yes, the molecularity is compulsory have the three natures. One is the molecularity is a theoretical concept actually. Okay, clear or not? It is a looks like a theoretical concepts, and as well as it is also cannot be zero. Okay, cannot be fraction, cannot be infinite, cannot be. It is a imaginary number. Molecularity cannot greater than the three. Okay, clear or not, all the students? Whatever the molecularity is there, it is not a practical concept. It is a theoretical concept only. Every time, whatever the things we are considering in this stoichiometric equations may not have possibility to take like that. Okay, clear or not, all the students? Yes, suppose I am taken there is a whatever the H2O2 it is there. Okay, this H2O2 is not taken, not a gives for us. Suppose I am taken, this is the equation. Suppose what is this equation? Carbon plus oxygen is given as a carbon dioxide. Okay, now how much molecularity of this? 2. Okay, clear or not? Yes, and the same that is I am taken carbon monoxide is a sorry. Yeah, I am taken it is a practically CO2 is a possible to here like this one. Okay, understood all the students. Suppose I am taken 2 plus CO2. It is not a possible to give the only CO2. It will be gives more than that also. It is a practically possible. No, not it is a possible. Theoretical manner, it is a correct only. Otherwise, I am taken HCl is a combined with the zinc. It will be gives a lot hydrogen gas and as well as the chlorine gas. Sorry, hydrogen gas and as well as the zinc chloride it is the form. Okay, now it is about how many molecules are there here? 2 only, but it is not possible theoretically. We compulsorily require the 3 molecules here in the reactant side. Got it or not? It is a theoretical concept only. The molecularity is a theoretical concept only. It is not a what? It is not a practical concept. In a practically, we have taken a more molecules for analyzing purpose. For a one molecule, how many products are made? For a calculation of this thing, for a one particular molecule, whatever the concentration we are taken, for that concentration, how many products make it? In this way, there is a whatever the we are considered that number of particles. Okay, now number of molecular things are a practical manner different compare with this theoretical manner. Understood not all the students? The molecularity component is a theoretical concept. And this molecular never become zero. The molecularity is a never become zero. And as well as the fraction also. And as well as the imaginary number also. As well as the infinite also. The molecularity is a zero, nothing but there is no reactant, there is no chemical reaction. Clear or not? There is no molecularity, no reaction or not. Yeah, like that there is a molecularity is a not a S zero. And it is not a become imaginary number. Imaginary numbers are different to come from the as our regular real numbers. Okay, clear or not? It is never become imaginary. It will never become zero. It is not a become fraction also. It is not possible to take a half molecule, half oxygen molecule. Like that, it is impossible to take. Okay, half molecule. Half molecules are a 3/2 molecules are like that. It is impossible to take. Okay, it should be compulsory natural number, none other the zero. Okay, clear or not? It's a start from one, whatever the number it is. Okay, but generally we have taken a molecularity for a chemical reaction is how much? 3 only. Molecularity, yes, for a reaction, how much it is? 3 only. Got it or not? The molecularity is the 3 only, not exceeded the 3. It exceed the 3. No, it is not exceed the 3. Okay, now, sir, how, sir? Every time 3 molecules are only there? No, not it is like that. 1 second, there is one equation is given here. 4Br, 4HBr, hydrogen bromide plus oxygen gives rise to H2O and as well as the bromine. This is the one type of equation. One more equation they given. Yes, manganese iodide. Yes, 4 ion it is combined with the 16H plus and plus C2O4 2 minus is right 2Mn plus 2 plus and next 10CO2 plus 8H2. This is a chemical reaction we are taken here. Understand all of you? 1 second. What is the molecularity of this equation? What is the molecularity? When we see that the molecularity looks like a 5. 5 or not? There is a 4 and as well as it is a what? 1. 4 plus 1. What is the molecularity of it is 5. But it is not affordable. The molecularity in the reactants is about 3 only. In a chemical reaction, molecularity should be 3 only. It not exceed the 3. Got my point? It not exceed the 3. So then how it is possible? Yeah, it looks like that, but it is not like that. Okay, clear or not? It is going on. Equation is not going in a single step. Is not like that. Okay, now yes. And 1 second. How many is there? 2 plus 16 plus 5. 23 molecular. Okay, clear or not? It is a 16, 5, 2. What is the molecularity? It is 23. But it is not like that. How? Yeah, 1 second. This molecularity is not 5. How it is? Okay, now 1 second. How there is equation is going on, you know? Yes, and HBr S plus oxygen, yes, gives rise HOOBr first it is like this it will be. And next there is the what? This HOOBr, yes, combined with the again one more HBr, it gives rise to HOBr. Next, this 2HOBr combined with the yes HBr gives rise H2O plus Br2, right? And it is 2 times it is occurs. Same reaction. 1 second, all the students, 1 second here. There is in this reaction, what is the molecularity here? What is the molecularity in this reaction? 1 plus 1. It is a 2 only. Dimolecularity. Yes, bimolecularity. 1 second, what is the molecularity of this? Bimolecularity. 2 only. What is the molecularity? Trimolecularity. Okay, 5 molecular. 3 it is. Okay, in this way the reaction is going on. Overall 5 or not? 1 second. 2 into HBOR. It is become what actually 4 into 2 into. There is we are taken 2 times here. Okay, now one more time also we are taken. This equation is only. What is that? H2O is double type. This reaction double type. How many HBr? 1, 1, 1, 1. And here how much is? It is into 2. 1, 1 plus 2. That is a 4 or not? Got it. Okay, 1 second oxygen. Only one time already. No oxygens in the intermediate. Got it or not? Got it? In this way, there is a molecularity that occur. More than the 3, it is not a possible. More than the 1 step may going on here. Okay, clear or not? In a single step, maximum molecularity is how much? 3. Okay, these are the about a molecularity. Got it? Yeah, I hope you got it. There is these equations are very important. The page number 20 and 21, whatever there you have to once you have to should check it. Okay? Yeah. Next. Then what is the molecularity totally? It is in the step 1 we are considering. Okay, not together we are not considering. Yeah, next after this. Order of reaction. How to find out order of reaction? Yeah, all the students, look at that. There is a what when you take one reaction here in the form of M1A plus M2B plus M2C is as product. This is product. Yeah. Let active moles of A, B, and C be A, comma B and C respectively. Okay, clear or not? Here A, B, and as well as C be the yes A, comma B, comma C respectively. Then the rate of reaction may become what? Actually, for this one, you know very well about that. And next, here, whatever the order it will be there, the powers of concentration of terms involved in the rate of law of reaction is only called what? Yes, order. You know very well already we are discussing. Yes, the rate law is written as a what? Rate law is equal to written as K into concentration of A, concentration of the B, concentration of the C. Got it or not? Already we have completed these concepts already. Okay, clear or not, all the students? A, yeah, 2A, somewhat a product it will be there. The concentration is a become what? A. Got it or not? That is only we are taken it is. Okay. Now there it is a 1, it is a 1, it is a 1. Some of these all the things are become order. Okay, now order of our reaction. Got it or not? Some of powers of a concentration terms involved in the rate law of expression is called as. Okay, now S is the order of a reaction. Got it or not? Yes, order is an experimentally determined quantity. It may be equal to 0, positive, negative, and fraction and greater than the 3. Infinity and imaginary values are not possible. Got it or not? This is only about the order here. Understand all the students about the order here. Okay. Now once check it here, not one these. These are taken from what given na M1, M2 and as well as the M3. Okay, the order is depending on these numbers, whatever they give. Okay, like this, A to the power of 2. In the last classes, we have discussed already about this. Okay, that is not a molecularity. Okay, now it is not a depending on a molecularity. Indirectly, it is a depending on molecularity also, but every time it is not a molecularity dependence. Why? Because the molecularity is a theoretical concept. This our order is a experimental process. It is not. It is a yes theoretical concept. Depending on experiment, it is only we are consider that order. Which order is a gives the which products. That is a totally depending on experiment only. The order is not depending on theoretical value. And as well as this whatever order we are considering. Yes, that order may become 0. Sometimes 0 order. Okay, no order may also possible for us. Yes, first order, second order, third order, like that it will be used. Okay, clear or not? But a finite value. Okay, not an infinite value. Okay, no, 0 is a possible, but exponential imaginary things are also not a possible. I hope you understood. Order is nothing but the whatever the powers after written the rate law for a concentrations. Okay, now the sum of the concentration of the powers of after the rate law written for a chemical reaction is only called order. Okay, order is nothing but first you have to take one chemical equation and write the rate law for that chemical equation. In that rate law, there is a concentrations powers are there. That powers is only called as orders. Okay, clear or not? Yes, this is only about the orders. And here, suppose they given somewhat like this here. A to the power of A, and B to the power of B gives the product somewhat. Now the what is the order? The rate law is what it is? Yeah, it is a become A and a B is like this. Now the order is a become what? The order is A plus B. Got it? The order is what? A plus B. Okay, got it? This is the sum of exponential numbers. Sorry, sum of powers of our concentrations. Got it? Yeah, this is only we are considering. Now we are going with that examples. Next, the examples on this particularly one second. What are they given? Yeah, 2H2O2 gives rise to H2O and O2. Okay. And next, here there it is also written as it is the step 1. This is the how many molecularities? Two for us now. Now how the reactions are going on? Step 1 they given what the here H2O2 gives rise H2O plus O. Okay, it is a slow reaction. And next, the O and O is combined together. It will be gives what? Oxygen. It is a fast reaction. Okay, they given like that. Step 2 reactions are given. Now one second, there is a whatever the rate of change. It will be actual rate. It will be written as actual rate is written as what is the actual rate here? That is only the rate that is only rate minus dx by dt is equal to taken as okay now what is that k of H2O2 okay H2O2 why because they are taken this reaction only. Understand all of you? It will be not we are consider these reactions. Only we consider this reaction only. That is only become the rate. Okay, the actual rate is depending on which thing concentration of hydrogen peroxide only. Okay, now yeah. Please note down this example. Yeah, in our textbook, they given somewhat experimental basis. There is given depending on that the order they taken. Okay, now don't confuse about that. There is the slowest step we are first we consider. In the slowest step, whatever the involvement it is there, that is only become the order here. We are not taking a fastest test here. Slowest one only we are considering. Okay, now don't confuse about that. The slowest one is only become the rate law purpose we are observed here. Yes. Next one, zero order. What is the zero order? Okay, na zero order reaction. Which one is the called zero order action? Okay, na action. The reaction is said to be zero order if it is if its rate is independent of the concentration of the reactant. That is, the rate is proportional to the zeroth power of the concentration. Suppose there is a one reaction is there. A gives rise no products to be zero order. Products are, it is taken as somewhat zero order. Okay, how we written the rate law, you know, the rate law is equal to written as minus dx by dt. It is equal to taken as dc by dt, and it is also written as k a to the power of 0. It is equal to become k only. Okay, clear or not? When there is a one rate of law of any particular reaction is equal to the rate constant, that is only called as what? That is only called as what? Zeroth order. Okay, how do we consider the zeroth order reaction rate here? We taken it is the dx by dt. That is integration. You don't know about integration, I thought it is. Okay, it is one of the mathematical component. Okay, now when we made the integration between the a to the x, it is okay now. That is only we have to write it is a minus x here. Okay, got it? Yes, and that will should become what actually? Yes, when we take it is yes into dx. This is the gives for us rate of reaction of the zeroth order. Okay, don't forget about this. Okay, now why? Because the integrations, about the integration you not know. Only the simple thing what you consider here, which is called the zeroth order, when the concentration power is taken as a zero. Okay, now when we are taken for reactant power is zero, that is only called our zeroth order. Okay, clear or not, all the students? This is only today's class, students. Here there is a simply concentration on molecularity and as well as the order of reaction. Okay, molecularity properties and order of reaction properties. Okay, now and tomorrow we'll go with the what? How to find out molecularity and how to find out the yes this order of the reaction. Okay, for a different chemical equation. Okay, now I hope you understood. Yes, thank you, Varanda.